Today we are going to talk about the fact that the square root of 2 is not rational. Now a number is rational if it's equal to the ratio of two integers. So x is rational if you can write it as a fraction where m and n, the numerator and the denominator, are both integers. So to show that the square root of 2 is not rational, well, we can do a proof by contradiction. We can suppose, to derive a contradiction, that the square root of 2 is equal to the ratio of two integers. Now what follows from this? Well, square root of 2 is the number that when you multiply by itself gives 2. So from this we would get that 2, which is the square root of 2 squared, is equal to m squared over n squared. And from that it would follow that 2n squared is equal to m squared, just by multiplying both sides by n squared. What does that give us? Well, the left-hand side of this equation is an even number. It's 2 times something. That means the right-hand side is an even number. So m squared is even. And that means that m is even. It's not hard to see that if the square of a number is even, then the number itself must be even. So that means that m can be written as 2 times something. I'll call it k. M equals 2k for some k. Now going back to this equation that we have that 2n squared is equal to m squared. M is equal to 2k, so 2n squared must be equal to 4k squared. And that tells us that n squared is equal to 2k squared. Now the same reasoning as before, since this is even, this must be even. So we get that n must be even, so it must be equal to 2l for some l. So what have we shown? We've shown that if the square root of 2 were rational, and were written as a ratio m over n, then both m and n would have to be even. That means that we could replace the square root of 2, instead of having m over n, we could replace it with 2k over 2l equals k over l. In other words, we could rewrite m over n as a fraction in lower terms. But now we're back where we started, because the square root of 2 being equal to k over l by the exact same argument is going to imply that both k and l are even. So we'll be able to continue this process indefinitely, repeatedly dividing the numerator and denominator by 2. And that's impossible, because eventually that would have to stop. So that tells us that the original supposition that the square root of 2 can be written as a ratio must be false.